Good afternoon, good morning, good evening. Welcome to the new video on chemistry. In this video, we shall discuss relative atomic mass of isotopic mixture. Relative atomic mass of isotopic mixture. That's what we are going to discuss. Isotopic mixtures, or of an isotopic mixture of an isotopic mixture. That's what we are going to discuss. And before I move to this topic, there are things you have to know. You have to know the symbol of an atom. When you have atom X of mass number A and proton number or atomic number Z. This is an atom X. A means mass number. Mass number. Another name for mass number is what? Is nucleon number. Nucleon number. Take note of that. Another name for mass number is nucleon number. YZ means what? Proton number. Proton number. And what is proton number? Proton number of an atom is what? Known as atomic number. It's known as atomic number. That means Z means for proton number, which you can also call atomic number. A is mass number, which is also known as nucleon number. Nucleon number. Take note of that. And the difference between A and Z is known as neutron number. That means I can say neutron number, neutron. Neutron number. Neutron number. Neutron number is what? Mass number, which is A, minus what? Z, which is what? Atomic number. Take note of that. Take note of that. For example, if I have an atom of sodium, for example, mass number of 23, proton number of 11. Look at this. This is mass number. The mass number of a sodium atom is what? 23. While the atomic number is what? 11. Take note of that. And atomic number is known as what? Proton number. The proton number is what? 11. Now, what will be the neutron number? The neutron number of this sodium atom. The neutron number will just be what? The mass number, which is 23, minus the proton number or atomic number, which is 11. Therefore, the neutron number is what? 12. Because you have to know that. You have to know that. Then let us move further. Let's move further. Before I move further into the topic, you have to know this. You have to know the meaning of isotope. Let me quickly explain isotopes. Let me explain isobars. And let me explain isotope. Let me explain these three things. What is isotope? Isotope is what? When you have two or more atoms of the same element. Take note of that, of the same element. Two or more atoms of the same element having different mass number but the same proton number. Take note of that. Let me repeat. Isotope. When you have, how can you know? Iso means the same. This P means proton number. The same proton number. Iso means the same. P means proton. Proton P. Iso the same. P proton. The same proton number. When you have two or more atoms of the same element, these two or more atoms of the same elements having different mass number but the same atomic. I told you atomic number is proton, but the same proton number. Take note of that. When you have two or more atoms of the same element having different mass number, the same proton number. Proton number means atomic number. Example of this: if I have hydrogen 1 hydrogen 2 1 hydrogen 3 1. I told you this is mass number for the first hydrogen, mass number, proton number. For the second hydrogen, mass number, proton number. For the third hydrogen, mass number, proton number. Can you see? They have different mass number. Let me write them beside each other. When you have this 1 1, another hydrogen 2 1, another hydrogen 3 1. Can you see? They have different mass number, the same proton number. That is what they call isotope. This is protium. This is deuterium. This is what? The name of this hydrogen is what? Tritium. This one is known as heavy hydrogen. Heavy hydrogen. Heavy hydrogen. This one form what? Heavy water. The symbol is what? D. Capital D. It can form heavy water. This one is radioactive what? Hydrogen. Tritium. Radioactive hydrogen. This one is what? The normal hydrogen. What will be the what? In this case, what will be the neutron number of this proton? The neutron number, I told you, is what? Mass number minus what? Proton number. This one, the neutron number of this one is 0. Neutron number of this one will be what? Mass number minus what? Proton number. The neutron number of this one is what? 1. The neutron number of what? This one is what? 2. That means I can simply say isotopes. They have the same what? Proton number, different neutron number. That's another meaning of isotope. When you have two or more atoms of the same element, having what? The same proton number, but different what? Neutron number. That's another meaning. Since they have different mass number, we have different what? Neutron number. Take note of that. Take note of that. Let's go to the next one before I move to the topic, the calculation under the study. The next one is for isobar. Isobar. And take note, another thing you have to know under isotope. Isotope. When you have isotope, let me take this as an example. Isotope. Take note, they all have the same chemical properties. Isotopes, atoms of the same element having different what? Neutron number, the same proton number. That means different mass number, the same proton number. Since they have different mass number, they have different neutron number. Also, the same proton number. Isotopes have the same chemical property. They have the same chemical properties. Take note of this. They have the same chemical properties. The same chemical property. But their physical property is slightly different. Slightly different. Their physical property is what? Slightly what? Different. They have the same chemical properties. Take note of that. Let us go to isobars. 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 Isobar. This one, isobar. When you have two or more atoms of isobar now, of different element. This one is different element, not the same element. Two or more atoms of different elements having the same mass number, the same mass number, but different proton number. but different proton what? Number. I told you proton number is known as what? Atomic number. Can you see this one? Please take note of this. When you have two or more atoms of different elements having the same mass number now, but different proton number. This one, two or more atoms of different elements. This one is for two or more atoms of the same element having what? Different mass number, but the same proton number. But this isobar, two or more atoms of different elements having the same mass number, but what? Different proton number. Let me give you example. Let me give you example. When you have this, argon 4018. You have potassium 4019. You have calcium 4020. Can you see this? Don't forget this symbol, Az. I told you A is mass number, Z is what? Proton number or atomic number. Can you see? Their mass number are the same, but their proton number is different. Take note of that. That is isobar. And take note of this isobar. This isobar, they have different isobars. They have different what? Chemical and physical properties. They have different chemical and physical properties. Take note of that. They have different chemical and physical properties. That is isobar. Let's go to the next one. Isotope. Isotope. When you have two or more atoms of different elements having this one having the same neutron number, but different mass number. This is mass number and proton number. I'll explain. I'll give you an example. That is isotopes. Isotope, two or more atoms of different elements having the same neutron number. Their neutron number is the same, but their mass number, that means their nucleon number, mass number, and their proton number are not the same. Take note of that. Example. When you have this. Example. When you have this. When you have this. For example, when you have carbon 14-6, oxygen 16-8, nitrogen 15-7. What is neutron number? As I told you, neutron number is what? Mass number minus what? Proton number. I told you that. In this case, they have different mass number. They have different proton number, but their neutron number is the same. Let us confirm. For oxygen, 14 mass number minus 6 proton number. 14 minus 6 will give you 8. Let's see this. 16 mass number, proton number 8. 16 minus 8 will give you what? 8. Let's see nitrogen. Mass number 15, proton number 7 rather. 15 minus 7 will give you what? 8. They have the same neutron number, but different what? Mass number and what? Proton number. Take note of that. That is what? Isotope. This one also, they have different physical and chemical properties. Take note of that. Then let us move to this. Relative atomic mass of isotopic mixture. I hope that you've understood the meaning of isotope now. Isotope. When you have two or more atoms of what? The same element. Having different mass number, but the same proton number, which is atomic. Let's move. Okay, let's move. Look at this. Let me take isotope of hydrogen. When you have hydrogen 1 hydrogen 2 hydrogen 3 Take note. Let me call the relative abundance of this X1. X is relative abundance. For the first isotope of hydrogen, relative abundance X1. For the second isotope of hydrogen, the relative abundance, let me call it S2. For the third isotope, relative abundance, let me call it S3. Where X, take note, where X, let me write it here, where X is relative abundance. And take note, relative abundance is expressed in percentage. Is expressed in what? Percentage. And addition, the sum of the relative abundance of all isotopes of an element must be equal to what? 100. Take note of that. Relative abundance is expressed in what? Percentage. And the sum of the relative abundance, the sum of all the relative abundance of what? Isotope of an element must be equal 100. Must equal what? 100. The sum of the relative abundance must be equal to what? 100. Take note. And the mass of this one, let me call it M1. Mass of this one, let me call it M2. Mass of this one, let me call it what? M3. Take note of that. Then for me to calculate relative atomic mass of isotope of what? Isotopic mixture of this hydrogen. It will be what? Mass of the first hydrogen, M1, multiplied by its relative abundance, S1, plus mass of the second hydrogen, M2, multiplied by its relative abundance, S2, plus mass of the third isotope of hydrogen, M3, multiplied by the relative abundance, X3, everything over what? 100. Take note of this one. Take note of this one. And I told you that addition, the sum of relative abundance of isotopic mixture of an element must be equal to what? 100. Take note of that. Take note of that. Take note of that. Take note of that. Please take note of that. If I have two isotopes, then let me say, for example, if I have chlorine 35.5 and chlorine 36.5, just two isotopes of chlorine, their relative abundance will be 2. That means the sum of their relative abundance must also be what? 100. Take note of that. Then for me to calculate relative atomic mass of this isotope, because there are two, it will be what? Relative atomic mass of these two isotopes will be what? Mass of the what? The first isotope, M1, multiplied by its relative abundance, plus mass of the second hydrogen, chlorine, M2, multiplied by its relative abundance, X2, everything over what? 100. If you have 4 isotopes, it will be what? Plus M4 times what? S4. Everything over 100. Take note of that. Take note of that. Let's do this question. Let's do this question. Pause the video and write this out before we move this. Yeah. Before we move. Let's look at this question. The first question says, if an element N exists in two isotopic form, these are the isotopes of the element N. And I told you, the figure on top is what? Mass number. That means the mass number is of the first isotope is 50. The mass number of the second isotope is what? 52. And now say the average atomic mass of isotopic mixture is 51.7. Average atomic mass means what? Relative atomic mass. Take note. Average atomic mass means relative atomic mass. Is given as 57 or 51.7. The question now said calculate abundance of each isotopic form. Take note of that. For the first isotope, this is the first isotope, 50. The mass number, that means for this first isotope, don't forget the formula I gave to you. Relative atomic mass equal to what? Mass number of the first isotope multiplied by what? Abundance of the first isotope plus mass number of the second isotope multiplied by what? Abundance of the second isotope. We have just 2 isotopes over what? 100. If we have 3 isotopes plus mass number of the what? Third multiplied by what? Abundance of the third isotope. Take number, we have 2 isotopes. This is the formula. For the first isotope, M1 is what? 50. X1, we don't know it in our life. Let me give it S1 because we don't know it. That's what we want you to find. For the second isotope, which is 52, mass number M2 is what? 52. S2, let me call it what? S2. We don't know it. That's what they want you to calculate. And don't forget, I told you sum of the relative abundance, the sum must give you what? 100. That means for the relative abundance, if I have x1 plus x2, it must be equal to what? 100. You know that? I gave you. I said it. Then I can make s1 the subject of the formula, or you make what? S2 the subject of the formula. Which one? Let me make S2 the subject of the formula from here so that I can get my x1. That means I will have x2 equal to what? 100 minus x1. Isn't it? I have this. Then let me go back to the formula. And I have relative atomic mass is given as 51.7. That means relative atomic mass is what? 51.7. Take note of that. These are the data that I need. Then let's go to the formula. Relative atomic mass is given as what? 51.7. 51.7 equal to mass number of the first isotope is what? 50. X1 unknown plus mass number of the second isotope is what? 52. 52. Can you see M2? 52. Then times what? X2. I don't know. Everything over what? 100. Then I have 51.7 equal to what? 50 times X1 plus, and what did I say from here? X2 is what? 100 minus what? X1 plus 52 into what? 100. S2 is what? S2 is what? 100 minus S1. Everywhere I see S2, I've changed it to what? 100 minus x1. Everything over what? 100. Take note. Cross multiply. You have 51.7 times what? 100 equal to 50x1 plus expand this bracket. Open the bracket. 52 times 100 will give you what? 5,200. That is 5,200. 5,200 or 5,200. 52 times minus x1 will give you minus 52s1. We give you minus 52s1. Then from there, multiply this. 51.7 times 100 will give you 5170 equal to 50s1 plus 52,100. That is 5,200 minus 52x1. What will I do? 50x1 minus 52x1. Collect the like terms. They are the same. 50x1, 52 minus 52x1. That means I will have 5,170 equal to 50x1 minus 52x1 will give you what? Minus 2x1 plus 5,200. This one move to that side. What will I have? 5,170. This one move minus 5,200 equal to minus 2x1. Then what will I have? This one minus this one will give you minus 30 equal to minus 2x1. Minus cancel minus. Divide both sides by what? 2. That means I will have 2 cancel 2. Therefore, 30 divided by 2 will give you 15 equal to x1. x1 equal to what? 15%. I've gotten my s1. Then how will I get s2? Very simple. s2, s2, s2. I told you the sum of relative abundance must be equal to what? 100. Since I've gotten my x1 as 15, just take s1 away from what? 100. We get s2. Even from the formula we have, s2 equal to 100 minus x1. Therefore, s2 equal to 100 minus s1 is what? 15. Therefore, s2 is what? 75%. That means, therefore, the answer is x1 is 15%. S2 is what? 75. I'm sorry? Now, 85%. 85%. 85%. 15 minus is 85%. 85%. Take note. That's that. Take note of that. Take note of that. Let's move to the next question. Let's move to the next question. You can pause the video and write the question out. Let me rub off. Let me rub off. Let me rub off. Hope you understand. Thank you. Let's move. Let's move. Madu, 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 madu. Mind yourself, mind yourself. Okay, let's go to the second question. Solution 2. Second question. Solution 2. Solution 2. What's the second question? The second question says the relative atomic mass of elements is, that means RAN, or I can write AR, relative atomic mass, or RAN, or I can write it like this. Relative atomic mass of that element is given as 21.5. The two isotopes of the elements are, this is the first one, the mass number. What I need is just the mass number. I don't need the atomic number. I don't need this one that is down. What I need is what? Mass number. Mass number. For this first isotope, X, of the element, this is the first isotope of the element, X. The mass number is what? 20. For the first element, that is M1, is what? 20. M1 is 20. And relative abundance is given in percentage. I told you it's expressed in what? Percentage. The percentage is what? 25%. Now this X1 is what? 25%. Take note. Not like the first one. They want you to calculate S1 and S2. But this one we are given X1 and S2. We are given relative abundance. We are given relative abundance. Let's move. Then the second isotope. Can you see? The mass number of the second isotope is not given. Automatically, you want you to calculate the mass number of the second isotope. That's why they say calculate Y is Y. Calculate Y. Calculate Y. Calculate Y. They want you to calculate the mass number of the second isotope. That means for the second isotope, which is N2, mass number is what? Y or no. The relative abundance, that means S2 is given as 75%. They want you to calculate Y. The formula is still what? REM equal to what? Mass number of the first isotope, relative abundance, plus mass number of the second isotope multiplied by relative abundance of the second isotope, everything over what? 100. Then from here, what will I have? Relative atomic mass is what? 21.5. 21.5 equal to M1 is given as 20 times S1 25 plus N2 unknown Y, that is Y. Then S2 times 75, everything over what? 100. What will I do? What will I do? Solve your mathematics. 21.5 equal to this one give me what? 500. I mean, yeah, 500 plus 75y over this. I mean, yes. From there, cross multiply. You have 21.5 times 100 equal to what? 500 plus 75y. This one give me 2150 equal to 500 plus 75y. Move. Move. You have 2150 minus 500 equal to 75y. This one will give me 1650. Yeah. Equal to what? 75y. I'm looking for y. Divide both sides by what? 75. Divide by 75. Divide by 75. 75 times 2, 75. This one will give me 75 times 2 times 2, 14, 16. Will give me what? 22 equal to y. Therefore, y equal to 22. That means the mass number of the second isotope is what? 22. Is 22. 22. Let's go to the next question. Let's look at this third question. I will give you this. This one will be an assignment. I will just explain how you can do this. This will be an assignment. I will do the third one. I will give this to you as an assignment. Then you can drop your answer under the comment section below, or drop your answer in the WhatsApp link. You see a WhatsApp link below this video. You can drop your answer there. You can join the WhatsApp or drop your answer in the comment section below the video. Let's move. Don't forget to subscribe to this YouTube channel. Our YouTube channel is for New Teacher School, the best online learning platform, where we give you the best for JAM, WAEC, JUPED, 100. We will prepare students from SS1 to what? SS3, WAEC, NEPO, JAM, JUPED, 100 level. Please take note. Science, engineering, medical sciences, biological sciences, physical sciences. Let's move. The third question says, an element X has two isotopes. This is the first isotope. The mass number is 20. For the first isotope, M1, mass number, M1 is what? 20. The second isotope, N2, mass number is what? 22. And their relative abundance are given in what? Ratio. You can convert the ratio to percentage, or you can use it like that. You can convert the ratio, that is 1 ratio 2, 3. For the first one, 1. For the second isotope, 3. 1 ratio 3. You can convert it to percentage or use it like that. If I want to convert it to percentage, I want to get the relative abundance of the first one in percentage, relative abundance of the second one in percentage. What is the total ratio? 4. For this one, the total ratio, first of all, the total ratio is 4. Then, for the first one, relative abundance, x1, for the first one will be what? The ratio of the first one is 1. That is 1 over the total ratio, which is 4, times 100 over 1, which will give me what? This one divided by this will give me 25%. And for the first one, x1 is what? 25%. Then for the second isotope, what is the relative abundance in what percentage? Times x2 will be equal to what? What is the ratio? 3 for the second one. 3. That means this second one, isotope, which has a mass of 22. Ratio is what? 3. Relative abundance is given in ratio, which is 3. That means 3 divided by total ratio, 4 times 100 over 1, which is this one times 300. 300 divided by 4 will give you 75%. Take note, 75%. Then I can now solve. RAN, that's what they want you to calculate, unknown. Relative atomic mass, that's what they want you to calculate, unknown. Therefore, relative atomic mass equal to M1 X1 plus M2 S2 over 100. Relative atomic mass equal to M1 20 times X1 25 plus M2 22 times S2 75 over 100. Therefore, relative atomic mass will give you this one times this 500 plus this one times this 1650 over 100. Relative atomic mass will give you 2150 over 100, which will give you 21.5. That is that. Or I can use the ratio like that, 1 ratio 3. I will still get the same thing. Let me quickly do that. Relative atomic mass equal to, for the first mass, 20 times the ratio is 1 plus for the mass of the second one, 22. The ratio is what? 3. Then I will use the total ratio, which is what? 4. The total ratio. 1 plus 3, 4. The total ratio, 4. Therefore, we have relative atomic mass equal to what? 20 plus what? 66 over 4. Yeah, 66. Therefore, relative atomic mass equal to what? 86 over 4. Relative atomic mass equal to 2 year, 1 year, 0.25. Yeah, 21.5. Take note of that. Take note of that. Quickly pause the video. I will write it. Let me explain the second one. I will just give you it. It's an assignment. It is an assignment. It is an assignment. Pause the video. Write out that so that I can rub it off. Okay? Just so that I can rub it off. Yeah, so that I can rub it off. Okay, look at this second one. Int assignment I want to give you. Relative atomic mass is given as 24. 3 isotopes are there in this one. That is the formula to use 3 isotopes. RAN equal to what? M1 X1 plus M2 S2 plus M3 X3 over 100. 3 isotopes. Then let's continue. Mass of the first isotope is given as 24, M1, 24. Mass of the second isotope, M2, 25. Mass of the third isotope, M3, 26. Relative atomic mass, 24.3. They now say the LPS one, the relative abundance for the LPS one is 11.7%, Which one is the earliest one? This one is 25, 24. This one is 24, 25, 26. The earliest one is what? 26. That means X3 is what? X3, relative abundance. That means X3 is given as what? 11. Then they want you to calculate the relative abundance of the lightest one. Which one will be the lightest one? This one. Mass 24 will be the lightest one. What will you do? You just, very simple, so that you know that the sum x1 plus x2 plus x3 is what? 100. x3 is the earliest one, and the relative abundance is given as 11. That means x1 plus x2 plus 11 equal to what? 100. Therefore, x1 plus x2 equal to 100 minus 11. x1 plus x2 equal to what we are? You are 89. Then they say find the lightest one. Relative abundance of the lightest one. Therefore, make S2 the subject of formula. S2 equal to 89 minus what? X1. Therefore, now come back to this formula. M1, 24. X1, write your X1. Plus N2, 25. S2 is what? 89 minus X1. Plus, that is X2. Change it to 89 minus S1. Plus N3 is what? 26. S3 is what? 11 over 100. Then you get your answer. Please drop your answer in the word comment section, or you see WhatsApp link below. You can touch it and drop your. Don't forget to subscribe, please. We remain ourselves new teacher. You can call any one of these two numbers if you want to speak with any one of our word admin. God bless you. I remain myself, John.